Exercise 6 involves the function f of x equals x squared minus 3x, and we want to simplify f of x plus h minus f of x over h. This is a pretty involved problem, and it's an important kind of skill to learn that this formula here, this f of x plus h minus f of x over h, is a very famous formula from calculus. It's called the difference quotient. And if you go on to calculus, you're going to end up working with this thing a lot. Let's maybe call it the quote-unquote difference quotient. And so to figure this out, I'm going to break it down into steps. Because if you can write all this out at once, that's perfectly okay. But a lot of people, if they try to do it all at once, they get kind of lost in all the details. It's easy to do. So we're going to break this down into 3 steps. In step 1, we're just first going to figure out f of x plus h only. Okay. Now our function here is f of x equals x squared minus 3x. I'm just going to write my funny box notation. F of box is box squared minus 3 times box. And if I have x plus h in parentheses, then the x plus h has to go here, and the x plus h has to go there also, each position of the x from the original function. So I didn't recopy the original function there, just to make sure you realize where I got this from. And so let's just write this down in a more normal way. F of x plus h is x plus h in parentheses squared minus 3 times x plus h in parentheses. That x plus h squared is x plus h times x plus h. So I have to multiply that out. X squared plus xh plus xh is plus 2xh plus h squared. And distribute the negative 3. Minus 3x minus 3h. There's f of x plus h. That's what I got. All right, this big long mess. None of those terms are like terms. Step 2 is to now calculate f of x plus h minus f of x, which is the numerator of this fraction. So we're just going to work on the numerator. And my f of x plus h is, let's just recopy this so it, my f of x plus h is our answer from step 1. So I have to copy all that stuff. Minus f of x, I'm just going to subtract my function expression. So my function expression from the top was x squared minus 3x. But the crucial thing here is to put in the parentheses. So let's just note that the parentheses are essential. Why? Because to do this, we're going to have to distribute the minus sign. So let's go ahead and do that. Let's see if I can position this on the screen. And so what do I got? I got x squared plus 2xh plus h squared minus, so this is all equal to what's up above, minus 3x minus 3h minus x squared. And now I get minus a minus is plus 3x. So just notice getting that sign correct is just crucial here, okay? Noticing that ends up being plus. Because now I think I do have some like terms I can combine. X squared minus x squared is 0. And I have a minus 3x and a plus 3x is 0. So I still have a lot of stuff, but I have 2xh plus h squared minus 3h is what I end up with. This is the end of my step 2 now. Now in step 3, we're going to put it all together. So we want f of x plus h minus f of x all over h. Okay. And see, we already have that numerator. That's just our previous result. 2xh plus h squared minus 3h. And we're going to divide by h in that fraction. Now the magic of this difference quotient formula is that you should be able to factor out an h from the numerator. And here we can. Each term has an h factor, so I can factor out a h times 2x plus I have a h left from that middle term minus 3 for the third term all over h. And so I'm able to cancel an h up above. And I'm left with 2x plus h minus 3, no fraction now. That's as far as I can go. Those are unlike terms, cannot be combined. And that's my result for the difference quotient for this problem. An important formula from calculus. I'm just going to slide down to the beginning of the problem. And just notice how we broke it down into 3 steps. You're not required to do 3 steps, but I think it's a nice way to go. And there's our final answer down at the bottom. There are several of these to practice in the homework. This is something you want to learn to do with a variety of functions. Great practice with function notation, something you're going to have to use in calculus courses.